Hi everyone. In today's video, I would like to show you how I can open two Raspberry Pi camera version 3s on my Raspberry Pi 5, which has a dual slot for MIPI cameras, and be able to have my application open within a MPI message passing interface cluster, these two instances, so they are connected by MPI, and maybe down the line as an improvement to this, I would then be able to have these different instances share their camera feed with each other, so they can do some fusion on the data that's coming from each camera into each instance of the application. The reason I went about this way is because last year when I tried to open both cameras on my Raspberry Pi 5 within my OpenCV C++ application, the OpenCV running on the Raspberry Pi 5 has had some limitations opening both cameras in the same app, same instance of the app. This is not a limitation of libcamera, the libcamera stack that is part of the Raspberry Pi 5. Libcamera apparently can do that no problem. And in fact, I could have, one way I could have done it was by managing my cameras directly using libcamera and then bypassing OpenCV for that. But then that would be not as portable for me because my application is cross-platform. It needs to be able to work with cameras on Mac, Windows, Linux, non-Raspberry Pi 5 platforms, any other platform. So as a result, I'm choosing to stay with OpenCV, and since it's a C++ application, I'm using the C++ OpenCV API. So the Python OpenCV APIs might not have these issues. So this specifically was a problem that I encountered on the Raspberry Pi 5 with C++ OpenCV APIs, not being able to open multiple cameras simultaneously in the same instance of the app using the libcamera backend. So one solution I came up with was, okay, I'll just run my application twice, two signal instances, and one of them will open cameras 1, the other one will open camera 2, and I can see what's going on and display it in different windows that are each windows being managed by a different instance of the app. And that works. I can open, because libcamera can support that, OpenCV each instance of the application could open a single camera and present the camera feed on the screen, and I had no problem with that either. But it's a little cumbersome. I have to open each camera, each instance of my application in a different folder so they can have their own settings file. That way they know which camera to open, and so on and so forth. So it's just a little bit of a not ideal. Also, when I have two instances of the application running, the two are capturing data from each camera, their own camera, but they can't share this feed with each other. They can't work together. So that's a limitation for what I have in mind with my experimentations. So what I've been able to do, and I'd like to share it today, is that I've been able to use the message passing interface, MPI, and basically have MPI orchestrate launching of these two instances of my application on the same machine, same Raspberry Pi 5, as if it's a cluster with two nodes. Each instance is a separate node within the cluster, although the cluster is running on the same single machine. The advantage of this is now these two applications, they get their own specific IDs within the MPI network, and as a result, the application can go, and depending on its MPI ranking, it can go find its own separate settings file and know what camera to open. And by being connected through MPI, down the line, I can actually have these instances broadcast their camera feeds to each other, or send it to each other, or send it to a different machine using MPI for processing. So the MPI long term allows me to have more flexibility for what I have in my head for kind of things I want to play with and experiment with. I'm sure there's a lot of other ways to do it, but this is the way I'm thinking about. So since I've been able to at least open my application with MPI and have it launch 2 separate instances of my app, each opening a separate OpenCV camera through the libcamera backend on the Raspberry Pi 5, I'm one step closer to that. I'd like to at least show and demonstrate that today. So the cameras that I'm working with are these camera module V3s. They are a 12 megapixel camera. They're built around the Sony IM708 sensor. One of them is a standard field of view. It's 75 degrees field of view. And the other one is a wide angle, 120 degrees field of view. So they're normal cameras. They're not the no IR version. They're just these are the pictures that you see. And so you see here on my Raspberry Pi 5, this is my Raspberry Pi 5, RPi 8, which is the name of the machine. And you can see that they are enumerated. If I look at them with the cam-l program, they are enumerated. They're showing one of them is a Sony IMX708, and the other one is a wide camera. So this shows that I can go through libcamera and access both and enumerate both of the cameras in my system. Also, this is some of the information about my operating system running today. It's running Debian, Raspbian OS, Trixie version 13. It's running on this kernel 618, and it has a 4 gigabytes of RAM. And basically, this is just standard system information. So the first thing I would like to try is just running the application by itself. So the way I normally run it is I run it by just doing that command, which then the application goes, and as you see, it's capturing this image, and then this is the first camera, and it's showing that it's video 0, IMX708. And I'm only capturing 640 by 480 from both. The resolution I'm picking is that. So this is video 8 is the second camera. It's also an IMX708, but you can see this is the standard view, and this is the wide angle one. Okay. So normally I can pick with one instance of my application. I can pick whichever camera I want, and then say capture, and with the camera running, I can do some computer vision stuff on it. Here I'm showing a histogram on the right on the color image. On the left, I'm doing a time exposure, which since the scene is not changing, it's just going to stay the same. On the bottom, I'm doing some edge detection using finite difference method, and then on the left, I'm using doing edge detection using phase, the phase of the images. So I'm going to stop this now and then demonstrate how I can run with MPI. I can execute with MPI exec. I can execute, launch the same application, and just tell MPI that I want two instances of it. So MPI just goes and basically runs two instances of it. So you see this one is running on RPi 8, and this is instance 0. I'm going to move it to the right-hand side. And then this is the second instance, and I'm going to move it to the left-hand side. Normally, my application would remember the positioning of the screen, the windows, but there is some sort of an issue with the GUI, the desktop on the Raspberry Pi. This works fine on other platforms, but there is something that has to do with Wayland. So here in my on the first instance, this is the root node in the cluster of 2. These are the 2 applications that are joined in an MPI cluster. This would be the root node. Its ranking is 0. This is the child node, and its ranking is 1. I could do more if I had more cameras in the system, but at the moment I only have 2 cameras. So I can then run the application, and now you can see that it is able to run it and do the work that it normally does, and then click on the other one, and I'm able to run it and on the second one as well. And you can see the difference between the angle, the angles. The edge detection is working fine, and you can see the color differences using the histogram and some of the things that I typically play with here. The other thing that I wanted to point out is that I can actually have the audio, a single channel of audio, also displayed on both instances. So I could have the camera feed, and this way I can see the audio that the microphone is capturing while I look at the visual. Another thing that I had in mind is maybe having a separate instance of the application, just doing nothing but audio. So you have 3 applications in a cluster and in an MPI cluster, and they can share this the result of it. Each application instance can share its results with the others. But normally I could have as you can see, these 2 applications are using the same, opening the same microphone, so they don't have any problem opening the same microphone device. It's just with OpenCV and opening the cameras through the libcamera backend that there was a limitation. But fortunately, I think this solution will let me prepare for my next steps of things I want to experiment with. So I hope this information was useful, and hope to see you in another video.